So far in our discussion of performing surveillance on the health of populations, we've talked about measuring morbidity and mortality. Another way to view the health of a population is with life expectancy and related measures. This table comes from a World Health Organization document on health statistics for countries of the world. We see at the top that life expectancy at birth is reported, but what exactly does this number mean, particularly the at birth portion? How is life expectancy calculated? To estimate life expectancy, we actually need information on age-specific mortality rates. We also start with the size of our initial population of living individuals. Here we start with 100,000 living people who have just been born. This is the age 0 row. In each row, we will move forward in time and keep track of two things. First is the number of people who have died in this time period. This is the number of deaths column. And second, the total number of years lived by those who just died. This is the years lived column. Essentially, what we'll be doing to estimate life expectancy is getting the ages at death of all people in this population and then finding the average. Along the way, we'll also calculate the probability of living to a certain age in the last column, just as another metric of interest. So for those just born, this chance is 100%. Let's go through the process of filling in a row of this table step by step. In the age 1 row, we move ahead 1 year. The first step is to take the surviving population and compute the number of deaths. Here we have a living population of 100,000, and the mortality rate in this time period of birth to age 1 is 1,000 deaths per 100,000 population. So the number of deaths is 1,000. At the end of this time period, the number of people remaining in our population is the previous population size, 100,000, minus the 1,000 who died. So there are 99,000 people remaining in the population. For the 1,000 people who died, we make the assumption that they died at 1 year of age. This means that we can calculate the total number of years lived by these people. 1,000 people living for 1 year is 1,000 person years. We're going to keep adding to this value as we move forward through time through the rows of this table, and we'll eventually divide the total person years lived by the initial 100,000 population in order to get a life expectancy estimate in years. Finally, we can calculate the chance of living to age 1 as the fraction of the initial population who survived to age 1. This is 99,000 over the original 100,000. Let's do one more row. We move ahead 9 more years to age 10. The mortality rate for this age group is 100 per 100,000 population. So among the 99,000 survivors, there are 99 deaths. These 99 deaths decrease the surviving population from 99,000 to 98,901. Again, we make the assumption that the age of death for the 99 who die is the maximum in this time period, 10 years old. This results in 990 person years lived. And the chance of living to this age is the 98,901 surviving out of the original 100,000. We can continue this procedure for the rest of the table. Eventually, the mortality rate for the highest age group reduces the surviving population to 0. So to compute life expectancy, we add up all of the person years lived by the 100,000 people in our population, and we divide by this initial population size. This gives us a life expectancy of 80.73 years. So sensibly, life expectancy is an estimate of the average number of years lived by all people in the population. We need to make estimates based on age-specific mortality rates because it would be quite difficult to get the age at death of every single person in the population. So now we can clarify the terminology of life expectancy at birth. Life expectancy at birth is the amount that you can expect to live right when you're born. However, once you live to a certain age, say 50 years old, your life expectancy will change. Life expectancy at age 50 is also called mean residual life at age 50. It might seem odd that your life expectancy changes as you get older, but there's actually a reasonable explanation. The life expectancy of 80.73 years is an average of ages at death of everyone in the population, including people who died before age 50. These people who died earlier should not affect the life expectancy calculation for people who have already lived to age 50. So the calculations for mean residual life are identical to life expectancy at birth, except now we treat age 50 as age 0. The age-specific mortality rates don't change. We keep the same surviving population as in the previous table, and the chance of living to this age of 50 resets to 100%. We've changed the title of the years lived column to extra years lived to emphasize that the years lived calculation will treat age 50 as the new age 0. And as before, the first step is to move forward in time and compute the number of deaths. This is the surviving population size multiplied by this age group's mortality rate. From there, we reduce the surviving population by the number of deaths. And for those who died, we compute the number of extra years lived past age 50. Assuming that these individuals all live to age 60, the number of extra years lived is the number of deaths times 10 years. The chance of living to this age is the surviving population out of the initial population of 50-year-olds. And we can fill in the rest of the table in the same way. Once the table is complete, we compute life expectancy at age 50, also called mean residual life at age 50, in an analogous way as life expectancy at birth. We add up all of the extra years lived past age 50, and we divide by the initial population of 50-year-olds. This gives us a mean residual life of 32.325 years. We can interpret this as, once you are 50 years old, you can expect to live an extra 32.325 years on average. Note that this is not the same as life expectancy at birth minus 50 years. This distinction is important for life planning, usually for finances at older ages. We'll end the video with a brief discussion of two other measures related to life expectancy. The first is years of potential life lost, or YPLL. Years of potential life lost tries to capture how prematurely death tends to occur for a disease. YPLL is calculated for population and has units of person years. And the procedure is as follows. First, years of potential life lost is calculated for an individual by subtracting their age at death from a reference age. We pick a reference age of interest, say 75. The younger someone is when they die, the greater the years of potential life lost. Then we add up all of the YPLLs for all individuals in the population for a certain cause of death. The chart here shows an example using data from the CDC. Here, YPLLs were calculated with a reference age of 75 for several major diseases. A measure related to years of potential life lost is the disability adjusted life year, or DALY. DALYs follow the same concept as YPLL, but time spent living with disability or injury also contributes to the calculation. That is, one DALY is equal to 1 year of healthy life lost due to disability, illness, or premature death. It's meant to encapsulate both life expectancy and loss of quality of life. In summary, we've learned about how life expectancies are calculated. We use age-specific mortality rates to estimate the age at death for all individuals in the population, and then we estimate life expectancy with the average age at death. We noted that life expectancy at birth is not the same as life expectancy at older age, And we also learned about other measures of disease burden. Years of potential life lost measures the extent of premature death. DALYs measure burden through years of life lived with illness or disability and through years of premature death.